Hello everyone, welcome back to Minas Tech. In this video, we will see general concepts of microservice. I have 8 interview questions on this concept. So let's get started. This is the basic and foremost asked interview question to each and every Java developer. So what is microservice? Microservice is small, loosely coupled distributed service. Each microservice is designed to perform a specific business functionality and can be designed, developed, and scaled independently. It allows you to take large application and decomposes or break into multiple microservice components with narrowly defined responsibilities. Microservice with the Spring Boot framework breaks down complex application into smaller services, loosely coupled services, and easy focusing on specific business capability. Microservice with the Spring Boot framework break down complex applications into smaller services, loosely coupled services, and enforcing on the specific business capabilities. The microservice architecture promotes scalability and resilience, and we can integrate with different tools and technologies like Docker, Kubernetes, and use RESTful API for seamless communication and deployment in distributed environments. Tell some major reasons to choose Spring Boot for microservice development. Here are 7 major reasons to choose Spring Boot for microservice development. Embedded server. In the microservice architecture, there may be hundreds of microservice instances deployed at given time. We would like to automate the development and deployment of microservice at maximum extent possible. An embedded server is implanted as part of deployment application. If we take an example of Java application, then it would be jar file. The benefit of it is we don't require a server pre-installed in the deployment environments. So the first point why we choose Spring Boot for microservice application is because of presence of embedded server. Support load balancer. Another major point to choose Spring Boot for microservice development is it supports load balancer. In the microservice application, we need auto-scaling. Auto-scaling means that there are a lot of load coming to a particular service, like some more customers coming in and logging to the application, or maybe we are running some offer, so the product are getting huge demand and lot of people are purchasing my product. So to start load balancing, we should have some automated environment like Docker and Kubernetes, and using these tools we can create more and more instances of that particular service in case of high load. Auto configuration. Let's say we are building a microservice application and we have these dependencies like config, your service factory, connection factory, data source, and all these things. So we don't need to create those beans, and the same goes with the security also. In Spring Boot, everything is auto-configured, unlike the Spring MVC project. We just need to use the proper configuration to utilize a particular functionality. Minimal code using annotation. Annotations are nothing but it's a form of metadata that provides data about the program. Annotation do not have direct effect on the operation of the code. There are plenty of annotation available in Spring Boot that are highly useful and they minimize the code. Loose coupling. Spring from the starting days provide us 2 most important features to achieve loose coupling. One is IOC, which is inversion of control, and dependency injection. Dependency management. Dependency management is just a way of managing all the required dependencies. Working with dependency management like Spring Boot Starter plays an important role here. In Spring Boot, there are a lot of starter projects which are available like Spring Boot Starter, Data JPA, Spring Boot Starter Security, and so on. Open source. One of the major features of Spring Boot is it's open source and lot of vendor work on the open source. Now let's see what are the advantages of microservice. There are few points which we need to remember for the interview. Microservice is scalable and it allows individual components of the application to scale independently. This means that we are scaling one of the part of the application that needs to be handled more traffic rather than scaling the entire application. Flexibility. Microservice allows us to use different technology and programming language for different services based on the specific requirement. This flexibility allows team to choose the best tool for the job rather than being limited to a single technology stack. Resilience. Since microservice is decoupled from each other, a failure in one service doesn't necessarily impact the entire application. This improves the overall resilience of the application and reduces the risk of downtime. Deployment. Microservice allows to develop, test, and deploy scalable services independently using deployment cycles and quicker time to market for new features. Maintenance. With microservices, it's easier to understand, update, and maintain the code base since each service is smaller and focused on the specific functionality. This can lead to faster development and debugging times. Technology. Different services in the microservice architecture can use different technologies, frameworks, and database based on the specific requirement. This allows for greater flexibility and innovation in technology choice. Now let's see what are the disadvantages of microservice. Microservice is built with multiple services. So that means we have to handle each and every microservice smoothly. Complexity. Managing a large number of microservices can be complex. It requires careful coordination between teams and can result in the more complex deployment and monitoring environments. Network connections. With microservices, managing the communication between multiple services using network latency and serialization, deserialization of data is complicated. This can impact the performance of microservice applications. Deployment complexity. Deploying and managing a large number of microservices can be complex. It required a robust deployment pipeline and automated tools to ensure that updates are deployed smoothly and without downtime. Monitoring and debugging. Monitoring and debugging microservice can be more challenging compared to monolithic application. Since each service is independent, tracking issue across multiple services can be complex. Cost. While microservices offer scalability and flexibility, they can also increase cost, especially in terms of infrastructure and operational overhead. Managing a large number of services can require more resources and investment in tools and infrastructure. Now coming to testing microservice can more complex compared to monolithic application. It requires a comprehensive testing strategy that covers integration testing between services as well as unit tests within each service. Now let's see what are the challenges while creating microservice application. So before creating any microservice application, we need to understand the complete requirement and the business functionality. We have to design our persistent layer to connect database through each services. We can divide the functionality into multiple services and develop based on the programming language for different services. So these are few points where we may face challenge while creating microservices. Complexity. Services look smaller in microservice, but the whole system is complicated. We need to take care of all the service database and we need to deploy each of the service independently. Now coming to testing, for testing we need a different approach to write smaller services and rely on the other dependent services. This is different from traditional monolithic or layered application. Writing test cases will be more complex if service will be depending on each other. To unit test, the dependent service mock must be used. Data integrity. Microservice support distributed database architecture. Each service in microservice is responsible for its own data persistence. Data integrity or data consistency can be challenged in each situation. You may have to update multiple business functions of the application for some business transactions. For different service, we may have to update multiple databases. We also have to set up eventually consistency of data with more complexity. Network connection. Many small services in microservice application need inter-service communication. If services in microservice will have long chain of dependency, then it will become a more problem for maintenance. We have to design an API carefully. Versioning. If multiple services need to be updated at the same time, then without careful design, you may face some problems with backward or forward compatibility. Now let's see what are the difference between monolithic architecture and microservice architecture. So as we discussed, monolithic architecture is traditional approach to design software where the entire application is built in a single unit. In this architecture, all the different components of the application such as user interface, business logic, and data layer are tightly integrated and deployed together. Now coming to microservice architecture, in the microservice architecture, an application is built as collection of small independent services. Each represent a specific business functionality and capability. These services are loosely coupled and communicated with each other over the network, often using lightweight protocols like HTTP or messaging queues like Kafka. So monolithic architecture involved building an application in a single unit, tightly coupled unit, while microservice divided in small independent components. Explain service discovery in microservice. Service discovery is a process for identifying available services within a distributed system. In the microservice architecture, where applications are composed of many small independent services, service discovery plays a critical role in enabling communication and collaborating between these multiple services. What is service registry and why it is important? A service registry is also a service or directory where information about available services and their location is stored and maintained. It acts as vital component of service discovery by providing a central point for service registry, lookup and management. So service registry key points are service registration, service lookup, health monitoring, load balancing and dynamic updates. In our previous applications, we have configured Eureka Server and Eureka Client as service registry. So we have registered each and every service with Eureka Client and configured Eureka Server port.